Okay, good morning. Morning. Good. Okay, so let's start. We are used to have a lot of bugs registered in our bug tracking tools. We are also used to have bugs in our minds or written in our notebooks. But there are some bugs that appeared in the headlines. And we are here to learn from them today what they reveal about how you build software. This is our goal for today. And I don't know where. Here. Yes, good, not good. Okay, sometimes there are software errors that contribute to the bugs we found. But most of the times, we discover that bugs are not just technical stuff. We know that the way that we make decisions, I don't know if I'm pointing to the correct place. Yeah, okay. The know that we make decisions, humans like us influence the result of the software that we are developing and influence the decisions that we are making influence the result of the software that we are developing. So behind the software, behind the technical errors, we have some human decisions. And today, who is me? I'm Paulo Oliveira. I'm a QA engineer at Mindera. I work in the quality assurance area from over 18 years. And today, I work as a mentor also and a professor. I have a master's degree in computer science. And I'm here representing the Test Tribe community. That is a software testing community that we have here in Porto. And you can know a bit more about us. We have a stand here in this room. You are welcome to go there after this talk. Okay, what we are going to see today, we are going to see a plane that crashed, an app that paid millions, a rocket that exploded, a tiny error with a huge impact, and a bug that never happened. So some of these stories maybe you already know, but some will be the first time. So the first one, the first one is the 737 MAX airplanes that crashed in 2018 and 2019 and was responsible to lose 346, I don't know, this is not working, lives in these two crashes. The cause was a system that no one fully understood. What happened? They built a system called MCAS that is responsible to put the nose of the airplane aligned. And sometimes, it was not me, good. And sometimes, when the plane points up, this system is responsible to put it back. And MCAS was activated without any data and put the flights down. And the pilots lose control, and the planes crashed. The pilots were not trained to deal with this kind of problem. To be honest, they didn't know about this system because the company didn't write this in the manuals. So in the chaos, when it happened, they didn't know how to work, how to try to save the plane. And more than 300 lives were lost. So safety decisions were influenced by commercial pressure. There are some newspapers and some studies that said that due to these commercial pressures, they didn't write the information in the manuals. They didn't train and invested to train the pilots. And unfortunately, these crashes happened. And what we can learn from these crashes? First, that systems can be too complex, even to that ones that build it. So it's important for us to understand, to document, and sometimes, no, every time, it works not enough if you don't understand what you are building, or what you are working on, what you are testing. So this is very important. And we know that every day we pass pressure to develop, pressure to test, pressure to deploy, pressure to deliver, and sometimes this pressure compromises safety. This was the case of the 737 Boeing. So, complexity without clarity is dangerous. This is the message from this first headline that I want to pass to you. The second one was related to Robin Hood. What is it? I need to point there or there. Where? Here? It's not working, but okay. So Robin Hood is a company that do trade investments, that you can invest your money. And in 2019, there was a glitch of $1 million that users were able to exploit. With just $4,000, they could invest, they could trade $1 million. And imagine what is this for a lot of thousand people. What happened? Good. Okay. The app didn't do a basic thing, that is validate when you are with a negative balance. So they were with negative balance, and they could invest again due to these options trading. That is one kind of investment. This is very bad, sorry. Okay. Okay. They could stack $4,000 and stack and stack and stack and achieve $1 million. Okay. Okay. It's work on my machine. Okay, while they are adjusting. So they were able to invest this $1 million by user, and there was a collapse in the platform. There was a collapse in the platform because users shared this exploit in Reddit, and there was a lot of people that exploited this. So they have some internal checks related to this negative balance, but they failed and no one saw this. What we can learn from this? Financial apps, the financial industry is a very specific industry, it's a very sensitive industry that we need to take care more deeply, more near. So financial apps create chaos, okay. Testing only the happy path is not enough. And if you have money, users will explore, will exploit, and will find something, everything that's possible. So if your app handles money, assume that you will be tested by Wild. So it's very important to have 1, 2, 3 steps of validations and take more care about this. Now it's passing by himself. The third one, it's Ariane 5, a rocket that exploded in 1994, 6, let me remember, 96. And in just 37 seconds, the rocket exploded, was self-destructed, causing $307 million of prejudice. Where is it? 37 seconds. What was the problem in this case? We have a software that reused an old code from Ariane 4. And this old code was not adapted to the new one. Was not tested in this new scenario, in this new context. And they found that a 64-bit was converted to a float, was converted to a 16-bit integer, and what happened? An overflow with an unhandled exception. And when this happened, there was no signals, and the system just splitted the rocket and self-destructed. And there was a backup system that was pointing to the same code of the original one. That was not a backup system. If you are pointing to the same part of the code, it's not a backup. It's just another point of code. And what we can learn, if you are reusing code, you need to check and you need to revalidate for this new context. Another thing is that you could not assume that this code will work just because it worked before. Okay. And also that redundancy is important, but does not matter anything if you are just copying to the same flow. Okay, too quick. So legacy code can carry hidden risks, especially when copy blinded. The fourth one is related to Intel processors that in 1994, now I'm correct, there was a disaster due to just a decimal. What happened? This division, 4 million and blah, 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 to 3 million, should be 1.3338, but in Intel processors, the result was 1.3337. It's a small thing, but imagine that this processor is inside a surgeon robot, for example, that is making a surgery and trying to cut something inside you, and just a decimal could influence a lot in a life. They tried to downplay it. They spent too much time to take an action, but was publicly destroyed in that time. What went wrong? This was the part of the process, this small part here, the FDIV circuit, that were missing some lookup tables. And it's a case in 1 in 9 billion. So, but if you are the one that has the luck to have this wrong division, this was very bad. Intel didn't act fast, as I mentioned it, and downplayed the bug. What happened? Public pressure. They need to do a recall, and it costs around $500 million to be done. And what we can learn, that precision matters, especially when you say that you are precise and when you need to be precise. Also, transparency beats denial, always. You need to be transparent, even when this kind of things happens. And that it's a small bug, but it can shake all the industry, in this case, the processors industry. So if you lose trust, even correct math won't save you. And the last one was the Y2K. What is it? Good. I'm not Harry Potter, but Y2K bug, the bug that never happened in 2000. In Brazil, we call it the Millennium Bug. I don't know if you were from that epoch, that time. I was a teenager in 1999, and I remember reading the newspaper. I don't know if you know what is a newspaper. It's too old. But a lot of companies talking about this, the Millennium Bug will crash everything, maybe people will die, planes will crash. Never happened. But the problem was that computers started the years with only 2 digits. It was 1999, that was started as 99, and it will turn 00. What will happen? So it was expected that banks will crash, planes, and other things. So the legacy systems started only in 2 digits, the years, and now we can confuse the 00 with 1900. This could be a problem. What happened if I'm now in 1999 and turn back to the future? Could be. And there were massive efforts to solve this. Teams, companies, governments that worked together, but spent around $100 billion to solve this. It was solved. We are here to talk about this. And we learned that prevention works. But it's rarely celebrated. Okay? Short-term decisions could make future problems. So things that we're deciding now can impact in the future. I remember when I worked in the previous company that we developed a software for 10,000 users. And one special day, the boss, let's sell this software to that companies, and now we will have 5 million users. Of course, it didn't work. And we need to adapt, we need to invest, we need to fix, we need to improve, we need to scale, we need to test, of course. But we see every day these short-term decisions. But we need to see the future, the impact. And as I mentioned, that everyone played a role, devs, QAs, CEOs, governments, everyone together to make it happen. So it was a bug that didn't happen thanks to the people who took it seriously. We need to take things seriously every day. So, what these 5 bugs that made headlines bring to us? That we have poorly communicated decisions, we have rushed timelines, we have lack of empathy with users, we have reused code without proper testing, and we don't have systemic thinking to think about everything that can happen. So, I hope that the next headline will not come from here, from inside this room, but could be just from a single line of code, could be from a rushed estimate, could be just from a yes that one of you say without think, without question, without helping other. So we need to fight against this. To finish, quality doesn't start with QA, it starts with the decisions we make while we are building the software. So because of this, we talk a lot about shift left, shift left, shift left. And we need to start not in the beginning of the project, but when we are thinking about what we want to develop, what we want to create. Other things that, no? Okay. You don't need to be a QA to stop a bug to appear in the headlines. You can just be you. You can just be a team member. You can just work together and act properly. Okay, we are a team. We are together. QAs are not the bad guys. Devs are not the bad guys, bad girls. We are a team. We should work together. In the end, everyone will be happy or everyone will be sad. So we need to work as a team. And we invite you to be in the stand of the test tribe. And if you go there, please let me know which of these stories made you think the most. Which of one of these 5, and what will you do differently in the next sprint to avoid this. I hope you enjoyed these good stories, and remember that good stories can save systems. So thank you very much, and that's it.